Okay, sorry, kind of got cut off. So we were talking about how we had a negative a value, so that means our parabola is going to open down. And we've already found our vertex is 1, 0. We found our y-intercept is -1. So because this is my vertex, I know I'm going to have this matching point over here. But we can use our table to help us prove it as well. If I put -1 into this equation for x, -1 squared is 1, but then I make it negative. If I put -1 in here, I get a -2, so I have -1 minus 2, which is -3, minus 1 more is -4. So I can find at this point, -1, -4 would go right here, which means I should also have this corresponding point here. In my table, if I put 0 in for x, then I'm going to get -1, and that was my y-intercept. I already had that. If I put 1 in for x, then I get -1 plus 2, which is 1, minus 1, which is 0. And I already had that point because that was my vertex. So now if I put 2 in, I can find that the point would be 2, -1. And I can connect the points in my parabola here. And I can see that my only solution is x equals 1. So this is an example of a quadratic equation with only one solution. Before, we had a quadratic equation with two solutions, x equals -1 and x equals 3. So let's take a look at another example here with no solution. So if we're going to graph this, I first need to get it into ax squared plus bx c form. So I'm going to subtract 4x. So this will become x squared minus 4x plus 7 equals 0. So my y-intercept is now going to be positive 7 because my c value is my y-intercept. I have a positive a value, so I know my parabola is opening up. Let's find my vertex. So I'm going to start by finding -b over 2a, and that's going to give me the x-coordinate of my vertex. So my b value is -4, so I have -4 over 2a, and a in this case is 1. -4 makes +4. 2 times 1 makes 2. 4 divided by 2 is 2. So that's my x-coordinate. I substitute this back into my equation to find the y-coordinate of my vertex. So if I put 2 in here, 2 squared is 4, minus 4 times 2, which is 8, and then plus 7. So 4 minus 8 is -4, plus 7 is 3. So my vertex is over 2 and up 3. I can now make a table to find the rest of my points, but I should expect this parabola to open up because of my positive a value. So I already have an x value, or I already have a y value for when x is 0. Let's go ahead and put 1 in, and it should be somewhere in between 7 and 3. So if I put 1 in for x, this will be 1 minus 4, which is -3, plus 7, which gives me 4. If I put 2 in to my equation, then I should get out a 3. 2 squared is 4, minus 4 times 2, which is 8, plus 7 we've already done. So we know that this point is 3. So let's test when x equals 3. So if I put, let's change colors here. If I put 3 in for x, 3 squared is 9, minus 4 times 3 is 12, and then plus 7. So 9 minus 12 is -3. -3 plus 7 is 4, which makes sense if I know that this is my vertex because this is my axis of symmetry, so all of my points should have a mirror image across my axis of symmetry. So we would expect when x is 4 for y to be 7. And let's look, if I put 4 in here, 4 squared is 16, minus 4 times 4, which is 16, plus 7, that does in fact give us a 7. So here's my parabola. And this has no solutions because it never crosses the x-axis. Now the next thing we'll talk about is finding the zeros of a quadratic function. But because a zero of a function is the same as an x-intercept of the function's graph, then you can use the function's graph to find the zeros. So all I'm going to do is the same process. I'm going to graph this, and I'm going to use the x-intercepts as my zeros because those are the same thing. So I'm going to start by graphing my y-intercept, which is positive 12, except that my graph won't allow that here. So let's move on to finding our vertex. So to find my vertex, I'm going to find the x-coordinate by taking negative b over 2a. So in this case, negative b would be negative 8, and 2a would be 2 times 1. So negative 8 divided by 2 is negative 4. So that's the x-coordinate of my vertex. Let's substitute that into my equation to find the y. So negative 4 squared would be 16. 8 times negative 4 is negative 32. So we end up with 16 minus 32, which is negative 16, plus 12, which gives us negative 4. So we have our vertex. So let's graph that, negative 4, negative 4. And because I have a positive a value, I know this parabola is going to open up. So now let's go ahead and make our xy table and see what other points we can find. Okay, so considering where my vertex is, I'm definitely going to want to look at the points probably negative 6 and negative 5, and probably negative 3 and negative 2. So if I substitute negative 6 in here, negative 6 squared is 36, and 8 times negative 6 is negative 48. So I get 36 minus 48, which is negative 12, and then I add 12, and that gets me back to 0. So it looks like we have found a root, negative 6, 0. So I would expect that my other root should be right here, but we'll check it in our table. If I substitute negative 5 into the equation, negative 5 squared is 25, minus 40, because negative 5 times 8 is 40, plus 12. So 25 minus 40 is negative 15. Negative 15 plus 12 is negative 3. So let's come graph this point, left 5 and down 3. So I would expect this point to be negative 3 as well. Let's double check it. If I put negative 3 into my equation, 3 squared is 9, minus 24, plus 12, because negative 3 times 8 is 24. So 9 minus 24 is negative 15. Negative 15 plus 12 is negative 3. And it looks like we have plotted correctly. Finally, if I substitute, I'll use black, I guess, negative 2 in, then negative 2 squared is 4, minus 16 plus 12. 4 minus 16 is negative 12. Negative 12 plus 12 is 0. So it looks like we have plotted these points correctly. So here is our parabola. So if I need to know the zeros of the function, and those would be -6 and -2 because they're my x-intercepts. All right, sometimes we might have to approximate these because when we graph our parabola, they are not going to cross in an exact location on our graph. So we're still going to follow the same process, but when we are reading these x-intercepts, we're going to have to approximate them. So I'm still going to start by plotting my y-intercept if I can, which in this case is going to be a +1. I'm going to find my vertex by doing -b over 2a. So -b would be a -4 over 2 times 1, which is -4 over 2, which gives me a -2 for my x-coordinate. And if I substitute that back in here to find my y-coordinate, -2 squared is going to be 4. 4 times -2 is going to be -8. So I have 4 minus 8, which is -4, plus 1, which is -3. So I have my coordinate of -2, or my vertex, -3. So I would expect that I should have a mirror image of this point because my axis of symmetry is going to run right through my vertex, right? So I should have a corresponding point 2 units to the left of this. But let's double check that with our XY table. And maybe in this case, checking -1 and -3 would be helpful. So if I put -1 into my equation, then -1 squared is 1, -4 plus 1. 1 minus 4 is -3, plus 1 is -2. So I can plot this point, -1, -2. So I would expect to have a point here, but let's substitute -3 into our equation to check. If I put -3 in, -3 squared is 9. 4 times -3 is -12. So I have 9 minus 12 plus 1. 9 minus 12 is -3. -3 plus 1 is -2. And that is indeed what I have. So I have points above the axis and below. So I'm going to have to approximate these solutions now because I can't tell exactly where these are crossing. So this one looks pretty close to -4, so I might say that it's about, so let me say approximately equal to maybe -3.9, and maybe this one is about -1/4. And again, we're approximating, so we're just trying to get close. And finally, if we have a multi-step problem, you've seen this equation before. We've looked at initial velocity in lots of word problems so far. We're going to write an equation that models the height, h, in feet of the shot put as a function of time, t, in seconds after it's thrown. And we have an initial vertical velocity of 29 feet per second. So I'm going to use this formula, and I'm going to substitute what I know. I also know my initial height from my picture here. Once I substitute 29 for V and 6 for S, because that's my initial height, now I need to factor this. So I'm going to use my AC method. AC is -96, and I'm going to break 29t into 32t and a -3t. And as I finish factoring by grouping, I set each of my factors equal to 0 and t